Now let's look at this last question, part question of paper 2005. This is going to be question 1G. State two different ways in which the wave model of light fails to explain the photoelectric effect. Explain one of the statements you make. So I'm going to use the simulator to talk about it. Now let's open our simulator. All right, so this is our simulator, and now we want to turn on this light. All right, so as you can see, if light only behaves as a model, then it will take some time. It will take some time for the photoelectric effect to happen, meaning that it will take some time for this current to have some reading. But in reality, as long as there is certain intensity, actually there is already the current reading. So it means that it happens without any waiting. See, if I turn this off and turn this on, the energy will be transferred. Yes, but it will take some time. Then it cannot explain why in photoelectric effect, when we have some certain intensity of light, we can immediately read something on this ammeter. Okay, so for the first part, we can write something like if light only behaves as a wave, then it should take some time to cause photoelectric effect. But in reality, it happens at once when the photon energy is high enough. High enough of knocking the electrons from the metal. Okay, so this is, I think this is going to be one way. You cannot use, like the wave side of light to explain the photoelectric effect. Okay, another one. Let's also look at this simulator here. Yeah, now we want to increase the intensity, like the amplitude of the light. Now let's maybe start from a dim one. Now from this dim light, we can barely see any of the, like the image. That means that um, the energy cannot be transferred this very clearly, right? Yeah, we need higher intensity, higher intensity to see clear of the light. Yes, yeah. But in photoelectric effect, we know that our energy, photon energy, is only equal to h times f, frequency of light, but not intensity of light. Okay? So what does it mean? It means that we can say if light behaves only as a wave, then higher intensity should increase the photon energy. But what is reality? But in reality, in reality, the energy remains the same for a specific light. So, light cannot behave only as a wave. It also has the particle side, and we call this duality of light. So this is one of my favorite questions.